Alrighty, we're going to look at three different multiple choice questions that use systems of equations and your knowledge of how to solve them in kind of some weird ways, just so we can, get some practice on not just random system of equations problems, but seeing what they might look like in a Regents exam. So example number one. Last week, a candle store received $355.60 for selling 20 candles. Small candles sell for $10.98 and large candles sell for $27.98. How many large candles did the store sell? So this word problem is an example of one of our amount and value problems, right? If you look at this problem, I have a total amount of 20 candles and my value is 355. I have small candles and large candles are my two things. So let's get to it. Let's set this up. I've got small, let's say, what's going on? Let S equal number of small candles and let L, I'll use L, equal number of large candles. For our amount, it's always just going to be 20 equals S plus L. It's just your amount value equals the two variables. And for your value, right, it's the amount and value problem. This is 355.60. That's going to be equal to the money, right? A small candle is 1098 S plus 2798 L. And they want to know how many large candles did the store sell. So let's do it, right? Let's copy this into the paper. 20 equals S plus L. And now 355.60 equals 1098 S plus 27.98 L. Here's our problem. Let's get to it. Now this one, you might say, all right, I see an S and L by itself. Let's do elimination. And you know what? Not the worst idea. So let's, sorry, not elimination. Let's do substitution this time. Though, elimination's like always easier. I don't know. Let me show you. You can even do elimination, just to show you, like, you can even do elimination with these crazy decimals. 1098S is the smaller one, so I'm going to use that as my number I multiply to. So the S's, I know if I just multiply this whole top one by negative 1098, these S's will cancel. I just got to be able to use a calculator to get this multiplication to work. So negative 10.98 times 20 is going to be negative 219.6 equals negative 1098S, and then negative, well, again, 10.98L. These are going to cancel out. That's the whole reason I multiplied by the negative 1098. Let's do this with a calculator. 355.60 minus 219.60 makes 136 even is equal to, the S is canceled, and I'm done. Now I got to do this. 27 minus 10 really, because those will go away. But just so you can see, 27.98 minus 10.98 is going to be 17L. Ooh, it also worked out that I eliminated the S's first because I was looking for the large candles, I believe. Divide both sides by 17. 136 divided by 17 gets me 8 is equal to L. Now, normally we're not done, but I believe this question was asking how many large candles did the store sell, and we just found that L is 8, so we are actually done at this point. We can go for answer choice 2. Let's keep going. Question number 2. Which pair of equations could not be used to solve the following equations for x and y? Now, this is a type of problem that relies on you knowing how to do the elimination method that we've been using so frequently. So let's take a look. I have 4x plus 2y equals 22, negative 2x plus 2y equals negative 8. Now in this, we're not quite ready to set up, but I could see maybe I multiply the bottom one by 2, so I end up with positive 4 and negative 4. Or maybe I multiply by negative 1 to either of these, so I end up with a negative 2 to a positive 2, or a positive 2 to a negative 2. Just getting ready to eliminate, right? And what they're doing in these over here is they're just showing different things you could multiply by to end up with these, and it's just saying which one could not be used to solve the following. So it's like, which one of these is wrong? So let's see. For answer choice 1, 4x, 2y, 22. 4x, 2y, 22. Nothing changed there. That's okay. 2x, negative 2y, 8. I started with negative 2x, positive 2y, negative 8. It looks like to go from my original to the bottom in choice 1, I multiplied everything on the bottom by negative 1. Negative 1 times negative 2 becomes positive 2. Negative 1 times positive 2y becomes negative 2y, and negative 1 times negative 8 becomes positive 8. So this one is okay because I multiplied the whole bottom equation by negative 1, and I did it correctly. Over here, let's see what we did. It looks like I multiplied the top one by 3. 4 times 3 is 12. 2 times 3 is 6. 22 times 3 is 66. That looks okay. And it looks like we multiplied the bottom one by negative 3. Negative 3 times negative 2, positive 6. Negative 3 times negative 2 is a positive 6. Negative 3 times positive 2, negative 6. Negative 3 times negative 8, positive 24. This one looks okay too. For this one over here, nothing changed on the top. On the bottom, it looks like I multiplied everybody by 2. Negative 2 times 2, negative 4. 2 times 2, 4. Negative 8 times 2, negative 16. So this one must be wrong, unless I missed something. Let's check to see what the issue is. This top one looks like I multiplied everybody by 2. 4 times 2 is 8. 2 times 2 is 4. 22 times 2 is 44. Ah, here it is. The bottom one, it looks like they multiplied it by 4. And so negative 2 times 4 is negative 8. 2 times 4 is 8. But they forgot to multiply this, right? Negative 8 times 4 is not negative 8. So the answer to this is choice 4. This is the one that could not work because they didn't multiply the entire bottom equation by the same number. They only multiply the left side. You're not allowed to do that. You have to multiply the same thing to both sides. All right. Choice number 3, question number 3. Albert says that the two systems of equations below have the same solutions. Determine and state whether you agree with Albert, and then justify your answer. So, let's see. They've got this and that. There must be a smart way to do this, but what I kind of want to do is just go about solving these, right? And see how it goes. Heck, let's just do it. I'm going to start by solving this second one because it looks like the second system, I can just divide this negative 8 over, find y, and plug it in. That's going to be a little easier. So I'm going to write the second system down. 8x plus, what is that? 9y equals 48. And then negative 8.5y equals negative 51. And this will also show another thing that you can do that, hopefully is a little easier to understand. Okay, so we are looking at this equation over here first because if I can just solve for y right away here, right? So I'm going to divide both sides by negative 8.5. Y is going to be negative 51 divided by negative 8.5. Y is going to be 6. I can plug this back into this equation here. So 8x plus 9 times, instead of y, times 6 equals 48. 9 times 6 is 54 equals 48. 8x. Subtract both sides by 54. Let's use a calculator just to make sure we're good there. 48, take away 54. 8x equals negative 6. Now this is going to be a decimal, but that is okay. Divide both sides by 8. So negative 6 divided by 8 is going to be, x will be negative 0.75. So I found that y was 6, x was negative 0.75. So I'm just going to write that out over here. Second system, y equals 6, x equals negative 0.75. Or really, I should be writing this as negative 0.75 comma 6 to have it as my ordered pair. Now, what I can do, instead of going through all the trouble of solving the second equation, is because I know that my solution for the second one is negative 0.756, is I can try plugging these numbers into my first system and see if it works out. So, and I'll write them side by side. 12x plus 5y equals 21. So I know that my solution for the second system, we just solved it, was this ordered pair. I should be able to plug this in for x, this in for y for both of these, and if it works for both of them, that means this is a solution to the first system. And if not, then Albert is wrong. So let's try it out. So I'll do 8 times negative 0.75 plus 9 times 6 equals 48. Let's do the little calculator here. 8 times negative 0.75, negative 6, plus 54. Ooh, this is looking good. Negative 6 and 54. Let's just make sure. Negative 6 plus 54 is 48 equals 48. This time it checked out. Let's plug it in over here. Maybe Albert was right. So 12 times negative 0.75 plus 5 times 6 should be 21. Well, 12 times negative 0.75 is going to be negative 9 plus, that's 30. Uh-oh. This is looking good too. So it looks like Albert was actually right, because 21 here I get is equal to 21. So it looks like this was a solution for both of these equations in my first system. So it means that, well, we solved the second system, found this as the solution, plugged this into the first system, found that it worked. So Albert must be right, because the points negative 0.756 works for all of my systems. Now, instead of doing this weird plugging thing over here, you could have just solved this by using elimination or substitution. But I thought this was a neat way to show solving it in a different way when you're dealing with two different systems of equations. And all I had to do was plug in here instead of solving. But you could have solved over there. Those were 3 examples of systems regions problems. And yeah, it's not always just kind of this straightforward write a system and solve it like we've been doing before. Sometimes they ask you some weird questions like, is it okay if I'm, multiplying, how does it work? Or let's compare 2 different systems. But as long as you know how to solve using elimination or substitution or both of them, and you can think a little bit about how the systems actually work, you should be good.